I told you just it is small topic, but still I'm not sure why you guys want to come offline only. Okay, database questions were there. What is this? Weak entity, strong entity. Finally, entity. Online, am I audible?
Yes, sir. And one more request. If it's possible, kindly lock the exposure, sir.
If possible, क्या होता है? You should let me know that. I think exposure is already logged enough. Okay, I think we have seen the concept of graph only, but in graph we have seen it using. Yes. See, there is one disadvantage. One is matrix representation we have seen. Yes. In that matrix representation, what is the disadvantage? Unnecessarily assume that there is no edge. From A to B, there is no edge. Then what I should fill in that place? Unnecessarily, I should fill 0. If I want to store 0, don't you think for 0 also some amount of bytes will be occupied? That is 4 bytes. Like that, you assume only there are 3 edges. Okay, not 3. Probably if there are 5 vertices and I have 1, 2, 3, 4, 5. 5 edges. You imagine there are 5 vertices and 5 edges. Okay, and if I write a matrix, how many zeros I will get? That way it is a unidirectional, you imagine. 5 cross 5 means 25 digits will be there, out of which only 5 will be ones and remaining all zeros. Don't you think it will be more or less a sparse matrix? Sparse matrix means what? More number of zeros will be there compared to ones. When you compare zeros and ones, the number of zeros will be more compared to ones. That we call it as sparse matrix. Means it is of no use because most of them are zeros. Clear with that point? That is the reason to overcome with that. Which is the other way? List representation. Okay. So previous, what was the diagram that I have written? I don't remember exactly. B, C, D. This one? First one. D to A. Okay. So for this, how exactly I can represent it in list? If you ask me, first, if there are 5 vertices, okay, this will be your A, B, C, D, and E. Now, first thing, in A, which is the first node I want to consider? It would be B. And A is connected to D as well. And A is connected to okay, this will be as usual. In a similar way, if I have to represent it for B, B 1, 2, 3. Which are those? It does not mean that D is connected to E, A is connected to D. No. We are representing it in that way. But ultimately, the concept remains the same. That is, B is connected to A, B is connected to D, B is connected to E. That is only the process. Next, what? This will be your everything. Yes or no? This will be your yes. This will be your A, B. Patience, huh? This is your in this, what is the benefit compared to matrix representation? Definitely, there should be some benefits at least. Then only we will be choosing this one over that one. There should be some benefit. What is that? Only whichever nodes are connected, we will be representing only those nodes. Unnecessary nodes will not be represented. For assume that here anyways I have considered bidirectional. Assume that only this many are there. This one and this one is also not there. Okay, overall 1, 2, 3, 4, 5 is only there. But to represent this in matrix representation, how many values we should store? 25. 25 into 4. How many? 100 bytes I need. Okay, out of which how many bytes are useful? 5 into 4. That is 20 bytes are useful and remaining 80 bytes are of no use. Getting my point? In that case, we'll be going with list representation. Okay, one is matrix representation, another one is list representation. Matrix representation is good only when the number of ones are more compared to 0. Okay, if at all, if zeros are more, then definitely matrix is of no use. Getting my point? Yes or no? In that case, we should go with list representation. Online? Quickly. Manual testing class is there today? No, right? Is there? At what time? Now there is no class, right?
Hello, sir.
Yes.
Is there any other marker, extra marker?
Not visible?
Yes, sir. Inflow is 2 hours, sir.
Okay, okay. But I believe the concept is clear for all of you. If I write in this, I think it will be difficult for me only to erase.
Yes, sir. No problem with this, sir. You use use another marker from next month.
Done with this? Next one was sorry.
A to D, D to A to C, D to D.
This one was done. In previous one, it was that. Now I'll shift to this. Any issues? Even if you have issues, I don't have any issues. Okay. So here, keeping all that aside, now how many I need? Definitely, as you just like the previous example, I just need okay from A. It is going to B as well as C. Yes. From B, D and E. Only outgoing nodes you will write in this. It is D and it is E. And here C to C and then D. Got it? From D, it is A, E. And then yes. Of course, this looks simple. The topic is simple only, but you should know, right? Whenever if someone asks you which are the different ways you have, yes, which are the different ways you have for representing a graph, that is adjacency. You can say it as other name is, you can just say matrix representation or otherwise adjacency matrix representation or adjacency list representation. Got it? Online? Yes. Done? Yes, no? Online? Next topic it is, not next topic, related to same. What exactly is the topic name if you ask me? Of course, it looks the same. but it is not about that concept. I'm just taking it as a rough example. Okay. Now, if there is a graph like this, okay, how can you traverse all the nodes? Means how can you visit all the nodes? Randomly, can you tell that I'll go first to here, then to here, then here? No, there should be some traversal techniques, right? If you speak about linear data structure, that is arrays, you are having something called as index number to traversal. Yes, stack, sorry, linked list, there is definitely a link to traversal. Link from one to another node, another to another node, like that, there will be link, you can traverse. And what else is left out? Queue, front and rear always is there. Yes or no? Circular queue, definitely you have circular connections. In that also you will use links. But here what is it? Here you don't have any such. Normally think, why exactly we have tree, right? This is graph. I mean, with respect to all the trees, pre-order, post-order, and in-order you can use. But when I say graph, this is for this one, you may say that you will use pre-order, in-order because it is looking like a tree. But it is not a tree. I told you it is a graph. Getting my point? Yes or no? So now if I have to consider, just rough example I'm taking, because next example, whatever I'll take, that will be more or less too complicated for you to understand directly if I do that. So I'm considering this. So there are two ways, one is here I'll write. First one is what is BFS? Here I'll write DFS, all of them. In name only it is there, breadth. Breadth means you should go with respect to width, not in depth. Okay, breadth means what? First, you consider A. Which are the, you should call, I can call it as exploration. Exploration means finding the adjacents. Which are the adjacents for this A? B and C. So take that. Yes. Now consider B. For B, which are the adjacents? And for C? This is your BFS. Means first you are going parallelly. Yes. But if it is DFS, how you will go? First you consider A. For A, which are all the adjacents that we have? B and C. Choose any one. For B, which are the adjacents? D and E. First you consider only D. But as there is no more, child for D, I will go for E. For E, is there any child? I mean, first you should check for D also. It is not there. So you will go for E. For E, is it there? No. So you will backtrack. E, D, B, A. Till here it is done. Next what? C. Okay. I mean, one time you will go till end and then you will keep coming back. Getting my point? That we call it as depth first search. This is a simple one. Next one I'll give. Done. For this one, I want you to write both. What is there to think so much? Done. Here I'll write it. Will that be fine? I don't want to write so much. 1 to 10 it is directly. No? 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 Sorry? No, if you have any doubt, you can ask. I'm just asking. So it is one breadth first search, right? Breadth means take it parallelly. One is having 3 adjacents, 2, 3, 4. And of course, now you can say, sir, 3 more, how we got, sir? Because each one is having only one child. Getting my point? If we had multiple, then the numbers would have been differed. Yes, here you assume that I had something like 11. If it is there, assume. Then in between 11 will come. I mean, after 2, 3, 4, in between I'll get 11, 5. But it is not there. Getting it? That is the reason, as there is only one single child, it will come 5, 6, 7, 8, 9, and obviously it is 10. But what changes? If you ask me, first you consider root. I know you know the answer, but again, process also you should know. Consider any one adjacent. Okay, there are 3 alternatives or adjacents I can call, out of which consider any one. Okay, which is that? I'll consider 2. It is not mandatory that you should consider 2 only. Okay, usually what we do is the first one, whichever comes, we'll consider that one. So here I should consider 2. From 2, from 5, from 8, from 10, 9. This one some of you will miss. 9 is also there. Okay, once it is done, next alternative means still here it is done. So next alternative, which one? Next it is 3, 3, 6, 8 is already done. Again, 10 is already done. 9 is also already done. So last but not the least is got it. And again, of course, you understood this topic. That is true. But here, what I just want to tell you is BFS can be BFS problems, whatever you have. Technically speaking, this is, theoretically or manually doing it, whatever I'm showing. But if I want to do it using, a logical program, then we should make use of something called as Q for and for DFS, it is in name only, it is there. Clearly, it is being indicated in name itself. What is that? Breadth means ultimately you need in this format, means horizontal. For that, you have Q. Okay, depth means vertical, because normally we will keep considering in this way. For that, you have stack. Getting my point? And how it works, sir? BFS I'll show. Okay, DFS later will think. First one, consider one node. BFS is this one, right? First, consider one node. Okay, and check. First, what you should do, whatever you have node you have, inserted. Okay, DQ it. You have added it to queue, right? Now DQ the friend. DQ means what? Remove the friend, and you attach it to BFS. Meanwhile, what you should do, whatever you are DQing, okay, check is there any adjacents for that? Is there any adjacents? No. Adjacents is nothing but alternatives or childs, I can say. Okay, is it there? Add all those. Getting my point? Now this you have attached to BFS. Yes. Next is what? 2. For 2, you check is there any adjacents? Yes, which is that? 5. Is there any more? I mean, for this one, apart from 5, is there any adjacents for 2? No, it is not there. So what I should do? Next, go for this one is done. 2, remove it and attach it to. Next one is 3. For 3, which is it? Apart from 6, is there anything for 3? No. For 4, that is 7. And you? Sorry. For 5, it is 8. Then it is 5 has been done. Somewhere something going wrong, I feel. 5, 6, 7, 8. No, it is right only. Here I am checking. So now 5, is it done? 5 is done, right? Only 1 it is. So here 5 will come here. Next 6.
8 will be repeated, right? 8.
8 is repeated, but one time if you do, if multiple people are visiting the same place, ultimately it does not make sense if I keep writing the 8 multiple times, right? Ultimately, it is the same place. Multiple nodes are incoming multiple edges. If it is there also or not there also, how will it matter? Ultimately, 8 is only 1. Multiple incoming edges are there. Fine. Getting my point? I'm not worried about, multiple incoming edges here. But as I've already told, every node should be, every vertices should be visited at least once. In this, am I visiting every node at least once? Yes. In this, am I visiting every node at least once? Yes. That should be the condition. Definitely, there will be multiple rows. Getting my point? So next, 8 is done. For 6, 8 is only there, it is done. Next, for 7, and 8 as And anyways, these two don't have anything. So just remove these two and attach it here. Some of you might think, sir, you have explained already these things. No, same thing you have written. I have explained you what you should write in a program. Not getting? I mean, you would have understood the process, but again, we should write a program as well. Simple here. What you should do is consider one node. How to consider that? Check. Okay. Definitely someone will be pointing to first node. Either it would be head or something. It depends on whether you are using array representation or it depends on if it is array representation, definitely where will be your first node? A of 0. If it is linked list, definitely you will have one pointer. Either it would be head, temp, it depends on how you write it. Getting my point? Say ultimately core logic remains the same. For tree also, for graph also, you will use same linear data structure only to represent it or to implement it. If you remember, trees, how exactly we used to represent it? Either using array or using doubly linked list. Linked list only, but we used to use doubly because there would be two side childs. Getting my point or not? Same way here also. Core logic, that linear data structure only we will use to implement non-linear data structure. If you want to understand, here there is nothing much. Whatever you have understood there, you should use it here. Okay, at least this I'm asking you to try, because if I explain this also, what is your part? Getting my point? Of course, I have not given any assignment, but I have asked you to type it. That is min max I have explained and I have written. Insert, delete I have given. So along with that, BFS, DFS, extra two methods I'm giving. What big difficulty? Again, if that is also not happening, ultimately I will only explain. Okay, but why I'm giving you for you people is at least one time think. Till now, whatever you have learned, probably from tomorrow, whether you will remember it again or not, I'm not sure. Will you remember it? Surely, I doubt, because once class is over, hardly I think anyone will remember that. Okay, so it's all up to you. However, please check. I believe this process is clear. First, you insert one element to your cube, that is root. Someone will be pointing to root, either if it is array 0 or if it is list, then it will be head or something. Okay, whatever is pointing there, store it in queue. And how to delete from queue, I believe all of you know. From front only you will delete, not from rear. Okay, insert will be from rear and delete from front. Okay, once you delete, attach it to some string called BFS and you can attach it there, or you can take one array and you can store it there. Next, what you should do? Check if there is any adjacents. If it is linked list, how to find adjacents? I believe all of you know. Left, right will be there. Okay, using that, you should add all those three here and start from first one. Okay, remove that and add it to BFS and check if there is any adjacents. Okay, same process repeats till last as well. So I just want you to try the program for this. Of course, I also know. And again, don't try to watch it on internet, because I will only explain. I will only explain. Probably in programming class, I'll do it. Officially, I'll conclude data structures, that is true. But again, insert, delete, as well as BFS, DFS. These four methods, if you don't write it, ultimately, I will only do it. Okay, but in the name of programming, I'll do it. Getting it? Okay. And same thing you should follow with respect to stack. Do you know the process of stack? Can you find what is the step we are doing for this? You by yourself. Last in, first out is there. I mean, again, I thought to give it to you. Ultimately, I should only explain. It's okay. Here. First, you start from anyone. Anyone means root. One you will insert. Next, increment the top, that you should write. That and all, I'll not explain. Okay, that should be written from your end. Alternatives. Take any one. 2 for 2. 5 for 5 for 8 9 is also having something. 3. What I should write next, that is different. First, what you should do, keep backtracking, means go in reverse way. Once you find the end, okay, then what I should do? I should keep backtracking. Why I should keep backtracking? Because if you want to check which is the node which is having alternative, still here you should backtrack, right? Yes or no? So now these all will be popped out. Means once you will go here, start popping it out. Means start removing. Once you remove it, you will keep attaching it to, which is it, DFS? Sorry. Of course, whatever stack logic I've explained and this will not match. Okay, I know that. But what I'm trying to say here is, once you reach dead end, then only you should backtrack. I'm just giving you an idea here. It is not the exact way what you should write in program I'm telling. If I tell that also, what is left out? Okay, you just have to write push pop, you should write. Apart from that, nothing is there in this. But again, you try from here and once you reach the dead end, okay, you will start popping it out. What I need now? First, for 1, you got these all. Okay, 2, 2, 5, 5, 8, 8, 10, 9. Once you reach dead end, start removing everything. And then what is left out? 1 is left out for 1. There are 2 more adjacents. That is 3. Now from 3 again 6. Okay, and remove those 2 also. And then 4. 4 is having 7. Remove those 2 also. Is there any more adjacents left for 1? No. That will find up this DFS. Getting my point? For BFS, DFS insert and delete of binary search tree. Getting my point? Can you try? I'm asking you to try. I'm aware of it anyways that I can't expect much. Okay, of course, some of you will definitely try, but I can't expect much from all of you. That much I surely know. Okay, but at least I'm asking you to try it. Ultimately, I'll explain. Clear? Yes or no? The major issue is that I don't want to speak in English. From tomorrow, I just have to check. I've informed you that I'll take it. I will take it. How many of you are not okay? Programming for tomorrow. 3 hours.
3 hours.
Sir, we can't say no, but we cannot say yes also. Something like that? No?
Yes.
Yes for what? Coming up.
Sir,
Yes.
sir, please check the DM in the WhatsApp.
In Zoom?
No, sir, in the WhatsApp.
In WhatsApp? You asked for timing.
No, sir, I have shared you the program for the binary search tree. I want to
I'll check
confirm
it,
that
sir.
right or
I'll
not.
check it. I'll check Chinmay. Okay, guys, then I'll just wind it up here. Sorry? Data structure officially will wind up, but unofficially here and there, I'll keep bringing it again. Okay. In between, I'll definitely bring it. Whenever I get time, I'll also take one more topic, which is not a part of it. I mean, if that is also covered, it is beneficial for you. Okay. In between, I'll keep giving it to you. Sir, what about those candidates who are attending only programming class? Sir, they will get bored now. What I should do? I don't mind if they're getting bored, what I should do. Programming class, anyways, I'm doing. Along with that, I'll give data structures also. Clear? So 4 methods I just want you to try. Those who can try it, please share the program. And also I will ask you to explain in next class. Okay, you can do that as well. No voice only. Sir, that writing is only big deal. Upon that, if you ask us to explain, we will not come to class only. Something like that. In programming class, anyways, going ahead, I think I'll get 8 o'clock to 9, 9 to 10, 10 to 11 as usual, 3 hours. I'll ask someone to explain. I'll ask someone to come and write the program. Here, offline candidates. So how many are there? You know everyone's name, right? I know maximum name. Your name, I don't know. New, I guess. Recent batch, right? Anyways, I'll get to know later. No issue. Others' names, I think I know. So those who are here today, from Monday, you should be there. Okay. Tomorrow also, again. From tomorrow, anyways, I'll not ask. Probably from Monday. Online candidates also be prepared. I may ask you to turn on the camera and explain it, or write the logic so that I'll copy it on board. Okay. See, why I'm doing this is because programming is not something like I'll by heart, I'll write as it is. You can never do it. Okay, even if you do it as it is, if I give same program, then you can do it. But if I change even a small thing, then you can never do it. Small changes, if I do also, you will not be able to do it. If you want, you can check it. Okay, I'll give it, I'll assign that particular tasks for you. I mean, whichever assignments are there, I'll give it to you. So you can check in that. You will only get to know that you cannot do it, even if there is a small changes. Getting it? So that is the reason my request it is, please try to involve yourself so that you can learn something. Okay. And I believe today also, did anyone have attended Tandem Loop interview? No. So there was one more company whose interview was there, which was asking coding round again. Okay. Nowadays, all the companies, not just one or two companies, all the companies will ask for it for sure. Okay. Not only for today. See, theoretically, if you are sound or not, theoretically, anyone can be sound just by hatting. But what makes you different compared to others? Logical or logics, the way you write it. Yes. See, by hook or crook, you should be able to get the output. I am not asking you to find the output for aptitude problems or mathematical problems. Even in programming, if they give some questions related to mathematics like permutation, combination and all, I'll just step away because I'm not sure. But if it is related to strings, arrays, and what else? Collections. These three, by hook or crook, I'll get it. They might be expecting only 3 lines, but I may write 10 lines also, but I'll get it for sure. It is as easy as that. Only thing is you have to practice on a daily basis, how it is working, why it is working. For loops, if you are confident, and scanner. Okay, rest everything is fine. You can learn it. Data structure means links. But programming, it is not about links, it is all about loops. Sorry? Data structure links are. Data structure is links, but programming is loops, I believe. More or less. The pattern is different. But going ahead, others are also there, right? That you have seen. You only bought that program, right? I don't know which one it was. Something, whichever. So like that, multiple programs will be there. Okay. And please remind me probably today or tomorrow, I'll create the document because multiple tests are going on. Whatever coding questions you are getting, please try to, add it there. Okay. Just write company name, add it, so that I'll, at the end of the session, I'll try to solve it. Okay. Saturday class will be there. Or Sunday, I should keep it. Second half only, obviously. No, 2. 2 o'clock because 1 to 2 will be your lunch break in your PG. Yes, 1 to 2 is lunch break. So it should not be something like, sir, I had sufficient, stomach full of food. Come here. And what will happen? You also know. Don't do it. If you do it anyways, how to make sure that you are not sleeping, I also know, but I don't want to take that step. For online also, I may ask anytime to turn on your camera. Monday or tomorrow, someone you offline guys, you remind me, okay? See, ultimately you guys are coming offline and you are sitting and you are listening to class because you don't have any other option. You can't sleep here. I will anyways not allow. But online guys, they may have a chance to sleep. Okay. So in between, just remind me that, sir, ask anyone to turn on the camera. Okay. I'll randomly ask. If they turn on, it's good. If they don't turn on, that is also good. Okay. For today, I'll wind it up here. We'll meet tomorrow then. Great.
8 o'clock.
Sorry?
8 o'clock.
8 o'clock.
Tomorrow. I think 8 to 11.
I need a break. Waking up at 8 o'clock. You guys know properly you will sleep at